So we are in questions and answers. Okay. Right.
Renata and Dario will answer everything.
Yes. That's the plan.
50 minutes ago, you demonstrated your knowledge of pronouncing iteration, but as you know, I filmed you while you were singing Big Mazzozza Everybody, and I put that on the Instagram, so you can go there. See how it works. Yeah.
If I said it, you can post it.
It was like 5 seconds, just 5 seconds.
Hello.
Hello.
My name is Thomas. I'm a creative director at an agency in Zagrebu, but I'm also a student at the University of Oxford, Artificial Intelligence Development Program. So, regarding the study of cognitive science and software, I have requested to join your faculty, but I was denied the access. But however, University of Oxford didn't find that problem. So today I am CEO of a company called Axiom Human. The company will be based in Denmark. And why is that? Because the Croatian strategy of development of future technologies doesn't have artificial intelligence in its development. So, therefore, I'm accepted and invited to the European Forum, Economic Forum, as professional consultant in strategic intelligence. So, we are actually building my profession, and I'm, as a CEO, I'm actually advanced artificial intelligence cognitive architect. So what that means? That means that I'm developing algorithms that are actually chain force. So what that actually means? Artificial neural networks simulate brain activities. Deep machine learning are technologies that are actually guided its responses via cooling, tech propagation, and that sort of thing. So my question for you is, does your work have major differences in correlation to Steven Pinker's theory of mind? Do you find...
That's already a question.
Okay.
And a big one, right? It's a very big one. I'm mic'd. So Steven Pinker is a friend. It's often the case, I just want to make that clear. It's often the case that Steven Pinker and I are on a panel because people want to watch us disagree. Yeah. He blurbed one of my books. He described it as a brilliant little book. And I'm very grateful to Steven Pinker for all the things that I have learned from him. However, in 1997, I published a book called The Literary Mind, and the final chapter is called Language. It's probably my most successful book, and that chapter begins by saying, you know, how can we explain language? And it reviews the sort of line of Chomsky, but getting to Pinker and Bloom, Steven Pinker and Paul Bloom. And I sketch out their theory, brilliant theory, and I say, and I think this is wrong. And then I go for an entire chapter outlining why I think this is wrong. And the reason I think it is wrong, briefly, and if Steven were here, I'd never get away with saying just these 2 sentences because these people are very highly trained. I do, however, feel that the theory that Pinker represents is largely being abandoned under evidence because the theory that somehow you had a genetically installed language acquisition device that provides essentially arbitrary, meaningless syntactic rules, who knows why, that are unrelated to human experience, unrelated to anything else, and you put words in this. This is words and rules, right? That has taken really an onslaught of evidence to the contrary from neuroscientists, from evolutionary biologists, on and on. So much so that Steven Pinker came finally to write a book called The Stuff of Thought, in which he takes a cognitive linguist's work, that's Lynn Talmey's, and talks about how important this is, and so on. So I think Steven Pinker is a moving target, and it's not the case that what Pinker published in Natural Language and Natural Selection in behavioral and brain sciences is what he thinks now. And what I want to say is, look, my feeling, my assessment after having worked 55 years in these fields is that they are embryonic. They're not even fetal. And that includes artificial intelligence, which changes every week that I'm watching it now, and has been changing since I started programming in Lisp, and things in linguistics and in child development, and on and on. These things are changing all the time. My own theories have been corrected, sometimes luckily by me, under new evidence, but sometimes by other people. And this is another thing I want to say about the institution. Human beings, where do we come from? How do we operate? Well, one way we operate is by having tribes and fighting each other, and we really get rewarded for that. The fact that I can get on that panel with other people and say, no, I think this evidence is wrong. In fact, blah, blah, showed in BB, and I cite this and blah, blah. I get a raise, right? Because we're on the map, and that's how it goes. Okay, that's fine if that's your motivation, and I can be motivated like that way along with the best of them. But we all overstate our case. We all, it's in the nature of human dispositions, we all are prone to interpret evidence in the way we want it. So I meant what I said. These fields are embryonic. They largely haven't been looked at. There's a lot of stuff that has not fed into it. We are just at the beginning, and we have to be humble. So, the question of who's right, chapter 8, I think Pinker's wrong. Who's right? I think the real answer is we're both wrong in some ways. That's got to be the case, right? And who's going to show us that we're both wrong in some ways? It's this class of 30 students who are investing in the integrated mind. By the way, I want to bond with you on trying to make things work. One of the reasons I put Red Hin Lab together is in order to get intellectual research to work, you have to get outside of the university to a certain extent. The university needs that pressure from the outside. It's called the Stanford model. At Stanford, it was very explicit that they wanted to have professors who had companies over here, because the company could do what it could do, and the professor could do what it could do, and the pressure on each other would make the university better. I think that's just right. So Red Hin Lab has hundreds of people worldwide. Great star here in Croatia, Professor Renata Geld, if you want to know about Red Hin Lab. And what we do is just what you did. Why do we go to Denmark? Because you can do this in Denmark. Why do we not do this here? Well, they have a tax. Well, here the EU has a regulation. That's all right. We've got Section 108 of the U.S. Copyright Act in the United States. We'll do that part here. Water finds its way. And you have to use that when you're in an institution. Water finds its way. You have to use, I'm talking to you 30 who are the first class of cognitive science now. It's coming from my heart, because this is, you know, I'm still that kid at Berkeley. You have to use the institution for what you want out of it, instead of letting it use you for what it wants out of you. And the university will be better for it. So I admire your entrepreneurship, and I admire your open-mindedness. That was a long answer, but you know, I tend to give long answers, I think.
Hello, thanks for the great talk. My question concerns the philosophy of mind. So I'm interested if you are familiar with the so-called hard problem of consciousness.
Sure, this is
coined by David Chalmers.
Yes.
And what are your thoughts on that?
Oh, it's a hard problem. And I don't think there are any really good answers to it. Patty Churchland and Paul Churchland are also good friends of mine. The idea that we should just get rid of this way of talking, and we say, oh no, not that, why does red seem red to me, but just I'm having this kind of spiking in these neurons. That's not a good enough answer. So the problem here is, remember when I went to my neurobiology teachers and I tried to talk to them, you understand, I did what you're doing. I got good grades and everything. I did the tests in neurobiology, and I can tell you about microtubules and, all that stuff. Great, I teach this stuff. But when I tried to talk about things like consciousness or creativity or development and so on, I understand. The idea was, look, that's sort of mystical. We don't want to deal with mystical things yet. We just want to do the hard science because the hard science will march up to getting to the hard questions. In fact, that didn't work at all. And so we had some really great neuroscientists like Antonio Damasio and people like that come to the cognitive scientists and say, what should we be looking for? We have all of this stuff going on, but we don't know what we're looking for. What we're talking about here is, first off, why is there consciousness at all? Why are you aware of anything? The problem is almost all the cognition you're doing is in the backstage of cognition, almost all, and you can't look into it. That's what cognitive science is trying to do, is to drag on stage a little of what's going on. Not only is the human mind not built to look into its operations, the human mind is built to not look into its operations. There are good evolutionary reasons for that. So how is it that why are you aware? And of course it's, how could I be aware and not, how could I think and not be aware? Well, you just look at all kinds of other animals. They seem to operate just fine. Evolution can set you up. Why are you aware? Well, I need to have the conscious mind so I can focus on the math problem so I can solve it. No. What is consciousness good for? Well, it seems to be good for, there's a little bit of agreement on this, it seems to be good for keeping you on track. It keeps you paying attention to something long enough that you can get it in the backstage of cognition. So you all know you had to learn how to read. And it was hard for many of you. Right? If you look at this now, you can't not read. There it is, boom, it just happens. You had to work really hard to get that into the backstage of cognition. And you were aware that you were working hard. So why are you aware, and why does awareness have certain features? So, for example, that white shirt looks white to me. It's a major question in physiology of vision, how you see color. If you think you know how you see color, you're almost certainly completely wrong. We have little cartoons. I taste something and this tastes like Neurodavila to me. Or this, why do these operations in neurobiology result in the detection and recognition of features? And there have been various kinds of answers. One answer is that's just an illusion, don't think about it. Just talk about neurons firing axons and stop being deluded. I don't think that can stand up under evolution because we all have this. It's very clear that evolution, to anthropomorphize evolution, natural selection selected you to be able to have these. It's extremely unlikely that there's not an adaptive a preference for these kinds of things. So why do you have them? You smell something, you have an instant memory. Well, we can point at the great advantages of it being in place. We can come up with just those stories of how it might have been adaptive. But explaining it from the philosophy, I think Chalmers is quite right that this is a problem that is a very hard problem, that all of the things in this area are very hard problems, and I have not yet heard an answer to the hard question of consciousness that I think is a settled answer. I know that's not very fulfilling, but I do think it is a hard question, and I do not think we have an answer. Yeah, I'm racking my brain about this right now and trying to come up with some research questions with my team and the Red Hen Lab, because, you know, AI has been around forever. I was born a few months before Alan Turing died. So so I'm not the reincarnation of Alan Turing, but my entire youth was freighted and fretted with science fiction and TV shows and movies and newspapers about AI, right? It's been around for a very long time. It didn't really capture the popular imagination, a real one. I'm not talking about Skynet or Ex Machina or something like that, but a real AI didn't capture the human imagination until, just as you say, they invented an interactive GPT, because you were evolved to interact in discourse, in conversation. You say, Mommy, why is the sun hot? Can I have a cookie? No, you can't have a cookie. Why can't I have a cookie? Well, the cookie will rot your teeth. Why will the cookie rot my teeth? You know, you're just back and forth. You're just built for it. And this was the first AI. I mean, they've been trying to do this since Eliza in the 1970s, but this was the first AI that was really impressive. You'd ask it something, it would come back. And they, in fact, trained it so that it would be more chattier. So instead of you asking it a question, you get a wall of text that was 750 words long. So it's like Mark Turner. You ask a question, you get 750 words. They trained it to be shorter, and it really dialed into what's going on. Now, the way these things work, as you know, they take massive amounts of data, and they use linear algebraic techniques to vectorize the data into a small model. These are models. And when you input something to them, they are predicting what is the most likely successor word for that input. And then given that word, and that word, that's what they're doing. They're predicting. I have some things to say about the relationship of that to the human mind, but mostly I'll say the way that is happening is not the way human beings think, but there are some interesting bits of overlap. Now, with that background, what I'm doing right now is investigating ways in which we can trick, prompt, guide these foundation models. They can be visual, they can be textual, now they can be sound. They compose songs for you, make films. Guide them in performances that a cooperative human being will regard as mimicking human creative abilities, including frame blending, metaphor, mathematical discovery. You know, you need the human being there because it's the human being that is the evaluator. The human being looks at this and responds. But the human being, although very impressed with the generative AI models, has not gotten to the point of seeing that they can do some of the things that we associate with higher intellect or with greater creativity. But, you know, ChatGPT has only been around for a year and a half, couple years, right? And I have trained on, I should say, Case Western Reserve University High Performance Computing. So I thank them for the GPUs that they have loaned me to train, and I thank the National Science Foundation. These are really, really early days, and that's just exactly the kind of question that we are asking. We didn't used to think that these things, these prediction models, would be able to do the things that they can do. We certainly didn't think they were going to be able to code, and now I don't know a coder that doesn't keep all the coding AIs open while they're coding and works 10 times faster than they used to. So it's early days. This is very ambitious. Somebody like Gary Marcus, whom I know very well, we spent a year together, would say, that's hopeless, Mark. You're being taken in by the AI hype. But I don't think so. And the only way to know is to try it. So look up Red Hen Lab. It's redhenlab.org. Or go to markturner.org, and you'll see a red hen. And you click on it, and you'll see the work we're trying to do in these areas. By the way, I think that if you're going to see, let me say one thing. when we get the coders that come in from India and China and all around the world, then want to work on Red Hen, we work on multimodal communication. The usual training they've had is the hard part is the coding. The hard part is to learn how to run a transformer. The hard part is, so they say, oh, listen, I'm really great, I'm really trained, I can do this and that and the other, and you give me your tagged data set, and I will run TensorFlow on it. And I'm a nice guy, so I don't say to them, listen, the hard thing is to get the intelligently tagged data set that's got the right theory for language and communication. I can get a 12-year-old from the junior high school across the street to run TensorFlow on it. So we have to negotiate. Everybody tends to think the thing they study is hard, right? But no, one of the reasons for having the integrated study of the human mind is there are all kinds of things that human beings are built to think are very easy. I'm working over here on this hard thing because I know it's hard. So why don't you just, why don't we get together and collaborate, right? One of the things you need to come to the study of these kinds of things with is an understanding of how hard it is to try to explain anything about human communication. Sure, a 3-year-old can do it. That doesn't mean we have explanations of how they can do it or how they can learn it. We're working on all those kinds of things. And I think that AI is going to push us because my view is that universities are the most conservative things anybody has ever invented. It's supposed to be about all new ideas, but no, it's your profession. You get paid, you establish your turf, you have your thing, you show that you're smart because you can do that and you can cite this and that. And that just tends to make things very, very conservative. You've got your stake, you want to grease your machine, but AI and corporations are going to help us break up some of that cement. By coming in, the corporations are now saying, listen, if you're not going to do it, we're going to do it. And you can trust that OpenAI and Google and Meta and all of those open source models at Hugging Face and so on, open to the world, open source. They're going to be pushing on this, and that makes me happy because we're going to light a fire a little bit under some complacent academic disciplines. So we're getting great questions here, and they're largely about a future that I'm interested in and want to work on, but I don't have solutions yet. Yeah. By the way, feel free to leave. I've kept you over time. I always do. But, this is my life. Yes.
The topic that we don't discuss that much, energy budgeting of the brain. Because we have basically infinite amount of energy to train these artificial neural networks. But brain and control hallucinations and perception of reality, human or any other kind of brain this planet has limited amount of energy. And evolution is super important. Your comment on that topic?
I run a little a discussion group called The Cognitive Angle. And what we've been working on in our little video conference, we have a lot of these sort of silent collaborations around the world, is energy and metabolism. And we've been looking at a range of papers on how you can't really separate science of metabolism and energy from science of thought. Because evolutionarily, you have this brain, right? And that brain is energy hungry. It just uses up energy all the time. There's vastly more caloric demand in order to run your brain than any other great ape has. Okay, that's a risk. You're not a boa constrictor. You can't eat a rabbit once every 3 months and do fine. No, you have to get this all the time. You have to get food all the time. Where will you get it? That's evolutionarily very, very risky. Moreover, this is important. You are using that energy all the time. If you think that when you're really burning up metabolic energy is when you're working hard on that crossword puzzle, you're working hard on that math problem, or you're arguing with somebody about domestic. No, it's your turn to wash the dishes. No, it's my turn to wash the, whatever it is, right? You think you're burning up more energy. That's false. Your brain is working major energy all the time. When you're sleeping, when you're dreaming, you're just going down in the train looking at a tree. There is a tree. No, you're using energy all the time. There are many of what are now called default networks that are running all the time, and they use up tons of stuff. By the way, it's very important. Don't make the mistake of thinking that metabolic activity, when you see this blood oxygen level dependent red and purple and yellow images of, oh, there's metabolism here. That's just how much blood flow is happening through the cells that serve the neuron. And here's something very important. Inhibition, that is not thinking but shutting down thinking, stopping things from happening, takes as much activation as anything. So when you see that red hole burning on that image, you say, wow, that amygdala is really active. That may mean nothing's happening because all of that energy is being used. Anyway, you have to use all that energy. You can't do much, although I've worked with DARPA, the Defense Advanced Research Projects Agency, on how to kind of supersize the soldier or the battle management, command and control person. How can you turn people into a Borg? How can you give them extra drug and computational abilities that make them able? Can you give them power drinks like Red Bull? Can you give, right? But there are some tight limits there. You can train them so that they're metabolically more efficient, right? So they're not using up so much energy. So they're not breathing all the time, so their heart rate is low. But pretty much it's really very limited. We're interested, but it's limited. Whereas what they're doing with these huge server farms is now they are investing in small nuclear power plants, little ones that they can put right next to the server farm in Iowa. So they can feed, not send it over long transmission lines, they can feed that all the energy you want off nuclear power. And this is going to make it has made a huge difference. I mean, these things never fall asleep. They work all the time. They're always there. They're super fast. You can't possibly compete with them on computer time, right? And the whole industry is going after this metabolic because, it's not exactly metabolism, but the AI is using energy, and energy is everything, guys. You have to have energy in order to have a life, in order to have a brain, in order to have the AI. So the energy dimension in this is huge, and all the people with money are paying attention to it. So for evolution and for AI, the energy question is just fundamental. And the winners are going to be the ones who manage the energy.
I wanted to ask, I've been reading up on conceptual metaphor theory and on conceptual blending. So I wanted to ask, what is the significance of the general space? Because
generic space,
Sorry, generic.
Yeah.
I've been reading up recently, so.
Yeah.
Because to me, it seemed kind of obsolete.
Yeah, no.
I'm not sure if I misunderstood something.
No, it's fine. It's a great question. So look, one of the things that success is difficult because then it's a success. So I one time drew a diagram that looks just like this. And it had 4 spaces with certain kinds of things, this generic input 1, input 2, and the blend. And it went viral. I had to put it on Wikimedia because I was getting requests all the time, can we reuse this diagram? But it's just a diagram, okay? Blending is a process. What I'll say about conceptual metaphor theory, my view, and I worked in conceptual metaphor theory. I have a co-authored book with George Lakoff. We published a lot of things together. We're great friends. I love conceptual metaphor theory. Is it a conceptual metaphor? How do they get there? A conceptual metaphor is a product, an entrenched product of conceptual blending, which is a creative, imaginative, on-the-fly operation, where the vocabulary has been exported to the target. It's like, love is a journey. Yes, we're on this road together, honey, and I'll be with you no matter what. Okay, we run into difficulties, but we'll get over them. Like that's an example of an instantiation of a conceptual metaphor. That's a case where the cross-space mapping is fixed, And the vocabulary has been exported so we natively use it for the target, and it doesn't seem creative that we're using those words for the target. Like, we're on, you know, we'll find our way, honey. You don't think I'm Keats or some famous poet because I said we'll find our way. I used words from The Journey and Finding the Way to talk about something that is in fact not a journey. Right, these are cases where conceptual blending has produced an entrenched product that you can activate. So from my point of view, conceptual metaphor theory is a great thing. And it's not that conceptual blending wants to like appropriate conceptual metaphor theory. It's got good stuff in it. We want to account for that too, including where did it come from? How does it change? Notice for an awful lot of blending, there isn't a fixed projection. In fact, George Lakoff and I worked together on generic level metaphors where there is no target, but you have a sense of what it might be. For some things, I can say time is a great healer, or I can say hospital bills are a great healer. You don't want to pay them, so you heal up really fast. That's not fixed. The doctor, the healer, went in one case to the passage of time and to another case to the fact that you hate. So that's not a conceptual metaphor. Blending is much more variable, and you can wake up the blending space. Now, the generic space. So in the first thing we published, which was a technical report, we had a long list about how this is a process, and not every case foregrounds the same operation. So in conceptual metaphor, you basically just see two spaces. Here's love, here's love, and here's a journey. Those are the ones you're aware of. You're not really aware of the blend anymore because you're not doing any active online creative work. You're using entrenched mappings that everybody already knows, right? The generic space is really crucial for certain kinds of operations. So, for example, in the mathematical invention of complex numbers, over here you have numbers. And you have operations on them like multiplication and division. You know, A plus B, I. And you can work, and you have two operations. You can add these numbers or you can multiply them. And one of those operations is distributive over the other. Multiplication is distributive over addition. And there's an identity element. So if you add things, zero is the identity element because A plus 0 equals, class, A plus 0 equals A. So it's an identity element for addition. And 1 is the identity element for multiplication. So 1 times C, where C is a complex number, 1C equals C. Okay, so each has an identity element. Every element has an inverse. So 3 for addition has the element -3, right? And on and on and on. You have an inverse. If you add 3, you can subtract it, blah, blah, blah. Point is, over here, there's the two-dimensional plane. And you can have a vector. And the vector can have a length, and it can have an angle. And I can show you vector addition and vector multiplication. So, for example, when you multiply two vectors, you do certain things with the vectors. In some cases, you add their magnitudes, their lengths. In some cases, I mean, you multiply their lengths, but in other cases, you add their angles. It turns out that and this was a major discovery in mathematics, it extended the range of numbers. You know, there had been counting numbers, fractions, rational numbers, we were talking about Pythagoreans, irrational numbers, which freaked out the Greeks, so you went to geometry instead of algebra for a long time. They were 0. Negative numbers, nobody knew what to do with negative numbers. In fact, there are a lot of the greatest mathematicians that thought if there were negative numbers, they'd have to be infinite. These things had to be invented, and they were invented through conceptual blending. You get the complex numbers, and then, of course, imaginary numbers, complex numbers, Hamiltonians, and so on. Well, it happens that there is a mapping between these two different operations, the complex numbers, and what you can do with vectors in a plane. And what they share in common is what we call a commutative ring. A commutative ring is an algebraic structure. And it's two binary operations. One's distributive over the other. Each operation has an identity element, on and on and on and on. A commutative ring is indispensable in mathematics. You use it everywhere all the time. Not having to do with complex numbers and not having to do with vectors. It's an algebraic structure that you can use all over the place. Okay, that's a case. The mathematician's discovery of that algebraic structure is the generic space, and it's indispensable, and it's genius. You also see generic spaces. See, the people who don't, they say to me, Mark, why do you have a generic space? You don't need it. Are usually looking at discourse. They're discourse theorists. They're looking at a text or an expression. Somebody says, okay, Zagreb is the Paris of Croatia, right? And they say, okay, I just map between these two spaces, and yeah, I see the blend, but where's the generic space? Why do I have to have a generic space? Okay, but you do need it. Mostly in those cases you can fudge and think you don't have to have it, but hold on, even in the case of text, if I say to you, you're reading a book of aphorisms, look before you leap. Can you make sense of that?
I mean, I guess, yeah.
Yeah, and what you don't have is a target because you don't know what I'm talking about. That's just an expression about the journey. But you understand it, even though you're not mapping it onto some other specific thing, right? You have an idea of what the aphorism generally, look before you leap, would mean. It might mean, hey, invest the tax law before you buy this car. It may mean, hey, this person you're thinking of marrying, how long have you known? It might mean, it might mean, it might mean. In fact, you can imagine all the applications of that. And that's because look before you leap, you create a generic space. And you think about all the places the generic space might apply. You got to have the generic space there. In other cases, when people are trying to solve a riddle and you need an analogy, and psychologists have them do protocol. Well, I'm this, that. What they're doing is trying to figure out what's the generic space that could be the shared structure. And they change it. And if you can't solve the analogy, it's because you couldn't find the generic space. So, it's not like, don't draw 4 spaces and try to put what in each kind of thing, right? Blending is a process, and I don't care what you call it. It's very complex. Our job is to take examples of human cognition and say, what do you think is going on? How do you think people do this? And if we agree on the process, then we agree. You can call it sausage for all I care. You can call it, we have this turf thing in the university. Are you on my side? Well, then you're using my vocabulary, my jargon, not that other person's jargon. We just drop the jargon, try to figure out what the process is. So in lots of cases, you can't get an explanation without pointing to the generic space, right? And I predict that you will find that the people who don't see the worth of the generic space are mostly the ones who are taking a little passage of discourse and thinking that they can do it without the generic space. Therefore, in general, we don't need the generic space, but they have no answer to things like commutative ring or a ton of other kinds of things where you really have to have a generic space. Now, am I wedded to the generic space or to generic understandings? I'm open to evidence that we could make the theory better, but you all have to listen to the evidence I have for why this has to be part of the process. Otherwise, there are all kinds of important things you can't explain. I told you just...
Maybe we continue to quantum mechanics and go to other ideas, but you know what about the whole session here, we can stay here and sing with that.
Are you sure I
wanted to finish like 5 minutes ago, but there was very questions for the last 10 minutes, so we have 5 minutes for a small question.
Okay. By the way, I can just teach the next class.
The question can be big, but the answer has to be small.
I love her.
She's always
she must be obeyed.
She always goes straight to the
Mark
point.
loves the
Yeah.
lectures. Yeah, thank you for your presentation. It was super interesting topic. I wanted to ask you, so you as a cognitive scientist, has seen a fair share of like a lot of computer science and linguists like connected together, and I wanted to know what's your opinion on machine psychology, or maybe to explain to others, applying like to construct experiments like from psychology to measure LLM's ability, cognitive abilities. Like, is it okay to kind of just, take these experiments and use them to evaluate LLMs, or should we be a bit more creative?
I have a brief answer. I also have a long answer. But my brief answer is the ELIZA effect. When ELIZA was invented, it's a computer program, and you say to it things, actually they typed in, hi, and it says hi, and ELIZA says, so why are you here today? And the person says, I just thought it'd be fun to talk to you. And ELIZA says, oh, so you thought it would be fun to talk to me? And the person says, yeah. And ELIZA says, so what kind of fun were you looking for? And the person says, I guess actually that's the hard question. Why am I looking for fun? And ELIZA says, is it because you were looking for fun that you came to me? Well, very, very quickly, people get emotionally and psychologically invested in this, even though they know perfectly well it's a machine. The ELIZA effect is famous in cognitive science. Human beings attribute intentionality to other agents. That's what I'm doing with you, and that's what you're doing with me, because I don't know your thinking, but I attribute to you viewpoint, attention. I have good reasons for doing it, but I can't actually see them. Viewpoint, attention, intention. So when you take a psychology experiment and you interrogate the machine, by which I mean you prompt it and it does something back to you, you're the one that is imputing to it mental operations and psychological operations. You have to be very careful, because we know that that machine can be doing it in a way that is nothing like the attribution or the imagination that you would have. It all depends upon the ELIZA effect. You have to have the ELIZA effect. We couldn't talk to each other if we didn't impute intentionality and so on to each other. But what you can't do is take the output that comes from the machine and say this is actually a psychological test if it behaves. If the output looks to me like what a human being would do, then I am applying this metric and I'm testing that thing's psychology. I think that's a category error. You have to be very careful with it. Okay, was that short enough?
So thank you, Professor Dan, for a great lecture and Q&A session, so we can thank you.
Hoodie from our...
Thank you.
Now you can go to the football game with the research. Hvala svima na dolazku. I know they collect